Here we have two draft horses that are pulling a tree stump with forces of 250 pounds and 280 pounds as shown in this picture. The angle between the forces is 60 degrees. We want to find the magnitude of the resultant force and then the angle between the resultant force and the 280 pound force. So first of all, let's go ahead and express each of these vectors in their component form. If we started down here with the 280 vector, 280 is all going in the x direction and nothing is going in the y direction. So that one's pretty easy to do. Now, if we want to know it for the 250 pound, we can just drop down a perpendicular line, and this is x and this is y, and we see that cosine of 60 is x over 250, and we can solve that for x, and we're going to get 250 cosine of 60 degrees. Similarly, if we wanted to involve the y, we've got sine of 60 is sine of 60 is opposite, which is y, over hypotenuse, which is 250. Solving for the y, we'd have 250 sine of 60 degrees. Now, if we added these two vectors together, we can do that. I'm going to put the other vector up here, and the resultant vector then would be somewhere like this. So there's our resultant vector, and the way we find that is we sum up the other two vectors. So our resultant vector is going to be, we add them component wise, so we got 250 cosine 60. Let's actually go ahead and simplify that. So we know what the cosine of 60 degrees is. That is 1/2, and then we also know what the sine of 60 degrees is. That's square root 3 over 2. So we could express this as 125 for the x component and 125 square roots of 3 for the y component. So to combine those two vectors to get the resultant vector, we add the first components, the 280 and the 125. And so when I add those two together, I get 405. And then we add the second component, the 125 square roots of 3, and I'm adding it to 0, so it's still going to be 125 square roots of 3. Now we're ready to find what we wanted to. We first wanted to know the magnitude. So the magnitude of this vector is going to be the square root of 405 squared plus 125 square roots of 3 squared square rooted. So let's go ahead and put that in the calculator, and it looks like we're going to round to 1 decimal place. We get 459.2 pounds. Now the other thing we wanted to find is from the 280, this angle for the resultant vector here. And so we know that that angle, we'll call it theta, is going to be inverse tangent of, for the resultant vector, the y, which is the 125 square roots of 3 over the x, which is 405. And so now we make sure we're in degrees, and we do inverse tangent. Put that in the calculator. We'll go to 1 decimal place. It looks like we get 28.1 degrees.